Hey everybody, this is 8.1, the free response question. We're going to do it, and each part is going to be a separate video, just that way we don't make it so long for all of them. Okay, so we're going to look at part A only. So let's just read through it. Mary and Chance walk in the same direction along a straight path for time between 0 and 20. 20, we don't know what it is yet. Mary's velocity at time t is given by m of t equals that whole thing, and Chance's velocity at time t is given by this whole thing. Both m of t and c of t are positive, so they're both going positive speeds. Okay, so they're not going backwards, and are measured in meters per minute, and t is measured in minutes. Mary is 12 meters ahead of Chance at time t equals 0, and Mary remains ahead of Chance at time for the whole time. So Mary is always ahead. Okay, so you can kind of think of this as like, here's Mary, here's Chance, and Mary and Chance are going this way, and they start 12, and then they're both walking in that direction. They never go backwards. They don't ever go this way. That doesn't work. And they just keep on going this way, and so Mary kind of goes faster, slower, she does some of that, but no backwards, right? And they both kind of just do that same thing. Okay, so that's the general idea of what's happening here. Okay, so find the value 1/10, 5 to 15 m of t dt, and using correct units, interpret the meaning of that thing in the context of this problem. Okay, so we are first going to write that. So part A, integral, and it's 1 over, it was 1 over what? 1 over 10, yep. And the integral was from 5 to 15 of m of t dt. Okay, so remember from the notes we had said, this whole thing is going to give us the area under the curve. And we also know that m of t, the units are in meters per minute, right? Meters per minute. So that means the integral units are in just meters. Okay, but remember when we were doing that whole thing, this part right here was kind of like the length. And where do you think the 10 came from? Well, it's 15 minus 5. So that 10 is really going to be, it's going to be like meters divided by 10 minutes. So our units in this case are going to be meters per minute. All right, so remember, this is the formula for an average value of a function. So that means this is going to give us Mary's, right? Her name is Mary. Yep. Mary's average velocity in meters per minute for 0 is less than or equal to t is less than or equal to 20. It's going to give us Mary's average velocity for the time that we're looking at. Okay? So that's what really we're looking for right here on this part. Okay, so what we're going to do is then we're going to type this into Desmos. So let's go ahead and get Desmos all fired up here. All right. And Desmos says, let's go ahead and we need to, I don't want that. I want the functions. I don't want this again because I can't see my functions. That's not helpful, Desmos. And then it goes from 5 to 15 of, and I should probably do the 1 over 10. So, oh, wow, does this not help? Not help at all. Oh my goodness. Wow, is this annoying? Okay. 1 divided by 10. Okay, and now we need to look at our function. And it was 6,010 divided by, we're going to say x squared minus 3x plus 50.5. Okay, so that's going to be, and we also needed to say d, not dd, but dx. Okay, so it's 54.409. Okay, so we can say this whole thing, the area is going to equal, and I shouldn't say area, that's not what I wanted, that integral of 1 over 10, the integral from 5 to 15 of m of t dt is going to equal, we said it was, 54.409. 54.409. And remember, that's going to be in meters per minute. So meters per minute. That's how, so we can say that's Mary's average velocity in meters per minute for the time 0 to 20. Okay, so there's part A.